Let's solve x by completing the square. We focus on x squared x. We write y equals x plus half the coefficient of x, which is 3, squared, minus 3 squared, which is 9. So this underlined part is the same as this underlined part here, all minus 3. We recopy this part here over here. Now what is minus 9 minus 3? We have minus 12. Thus, the vertex is the opposite of positive 3, which is minus 3, and the same as this y value, which is minus 12. Let's now complete the square on this one here, where the coefficient of x squared is not 1. First, always pull out the common factor 3. We have x squared minus 2x minus 1. This is the same when we use distribution as up here. We only now begin completing the square on this underlined part over here. So this equals 3 square bracket, all minus 1. Now this part here is quite long. It's going to be something squared, and that something is x minus 1. Half of negative 2 is minus 1. We go minus this number squared. 1 squared is still 1. We now use distribution. We have 3 times x minus 1 squared, and then 3 times negative 1 is minus 3, and this minus 1 remains over here. What is minus 3 minus 1? It's minus 4. So the vertex is the opposite of negative 1, which is 1 comma minus 4. This here is the general form of the quadratic. And we're going to complete the square by factoring out the a. So we have a x squared plus b over ax. We're just factoring out the a, and a times the second term becomes the second term up here. And we'll leave the c alone. We underline the part that we're going to complete the square on. And so we have this big bracket plus c, and we're going to set up a smaller bracket squared. And we copy down x plus half of b over a, which is b over 2a. And we're going to subtract this term here squared, which is b squared minus 2a squared is 4a squared. We can now use distribution. So we have a x plus b over 2a all squared, and a times this part here becomes negative. This becomes ab squared over 4a squared, and one of these a's cancel out. So this a on the top disappears, and this squared becomes exponent 1, all plus c. So what does this mean? This means that quadratics can be written in this form, where the vertex is the opposite of positive b over 2a, which is negative b over 2a, comma, the y value, which is this leftover part here, which is negative b squared over 4a plus c. So in general, the equation of line of symmetry runs through the x value of the vertex. Thus, x equals negative b over 2a. Let's prove the quadratic formula. X equals negative b plus minus the square root of b squared minus 4ac all over 2a. Previously we completed the square, and let's do the same thing again. We have y equals a x squared plus b over ax, we're just factoring out the a, plus c. So the idea of completing the square is what we're going to do right now, and ultimately we're going to set y equals 0, because when we set y equals 0, we find the roots of the parabola. Y equals 0 means we're finding the x-intercepts, which is what we're trying to solve. When we say solve x, we're finding the roots here and here. So y equals 0, and we're going to complete the square. Complete the square on this underlined part here. We draw a bracket squared, and we copy down half of the coefficient of x, which is b over 2a, minus this term squared, which is b squared over this squared, which is 4a squared. Using distribution, we have 0 equals a and then here we have a times this becomes minus ab squared over 4a squared. And like before, we canceled out one of these a's, top and bottom. So this here is a negative term. Let's throw it to the left. And what we get is a positive term, b squared over 4a. And this positive c, when we throw it over, becomes minus c. Minus c over 1. And this is the leftover part here. We have a x plus b over 2a all squared. Now let's divide both sides by a. By dividing this right side by a, we have to divide both terms by a. So this becomes a squared, and this 1 becomes just an a. And if we multiply top and bottom by 4, we have 4 here and 4 here. And we multiply top and bottom by another a, we get a squared, and we have an a over here as well. So now we have a common denominator for a squared, so we can combine this into one term. So the left side becomes b squared minus 4ac all over 4a squared. Now the right side here is all squared, so we can square root both sides. So continue on the left here, we have x plus b over 2a. The square disappears, and we're going to take the square root of this left side here. So it's going to be plus minus the square root of this business here. b squared minus 4ac all over 4a squared. So we take the square root of the top and the bottom, same thing. This right side remains the same. And we get plus minus the square root of b squared minus 4ac all over the square root of this 4a squared, which is 2a. Next, this positive b over 2a becomes a minus. So I'm just copying this again. Minus b over 2a. And again, we have a common denominator, so we can combine these into one term. Let's continue over here. We have x equals this whole business, minus b plus minus the square root of b squared minus 4ac all over 2a. And this is what we're trying to prove. We're trying to prove that this here, this formula, the quadratic formula, gives us the roots, also known as the x-intercept.